So we got everybody in?
Yep.
Hi, I'm Cliff. So how would your presentation go so far? Should I tell you how much fun surveying is? You get to travel the world, exotic places like landfills, underground mines, stuff like that. Okay. So I've been doing land surveying and surveying about 30 years. I know I don't look that old, but about 30 years, okay? So I've gotten to go to some fun places, but I do a little different than just surveying. So I do surveying in other applications too. So the surveying that I've done has been in law enforcement. So they use surveying tools for law enforcement to do crime scenes and accident scenes. There used to be a show on TV called CSI Miami, and one of my clients and one of my robots was in one of the episodes. We were only in the episode for about 10 seconds because in the scene they said for 10 seconds that we were there, they actually showed us do about 6 months of work because it's like, poof, there's your project, and they show all this. But the work that they did in that scene would have normally took about 6 months. But we wanted to bring something fun that we're using out here too, is a drone. You guys heard about drones flying in the air? Well, we use those too for mapping, for applications. But there are other applications where we're going to need something on the water, so we actually use drone boats, and we thought this would be kind of fun to bring out here. So what do you think, what places do you think we'd use a little drone boat for, like this one here? Not just pools, we kind of know this one, but where do you think we could kind of use it? Yeah. Ocean. Hey, TriDrone, you want to go out in the ocean in 10-foot waves? I don't think so, but it's a good choice. You're pretty calm. Go ahead. Ponds. You got it. So a pond, you know, there's a lot of fish ponds. There's a lot of golf courses. They all need the ponds. Why do you think we need to know the volume of the pond? Well, see how much water's in it. The other thing is to see how much sediment is in it. So over time, we need to know how the depth is changing. So this boat here is designed to go on small bodies of water where a human probably shouldn't go. So, you know, maybe Allison would like to go in the cesspool at the landfill, but most people don't like to do that because if you fell out of the boat into the cesspool, you would not feel too good. So we put this boat in places where humans shouldn't go, or difficult to go, like little ponds. And areas in Wisconsin up north are being mapped every day in people's ponds because the sand is filling up, and they need to know, because if it fills up too much, then they lose their pond. So what this is a TriDrone. It's got a sonar system on the bottom, and we can put other sensors in there to go look for things. We can put a sensor that looks for heat in the water. So if there's a heat change at the bottom of the water, we can find that. So that's what the TriDrone does. But indoors, she had mentioned that outside we use GPS. So we'll put a GPS head on this, and it will map with GPS, and that's a really easy thing to do. But indoors, why doesn't GPS work indoors?
Is it the roof?
It's roof. You know what? If GPS worked in here, we'd have to go back to the contractor and say, you didn't build the roof too good. But yeah, GPS does not work indoors because there's satellites over 26,000 feet up there that are broadcasting signals down to us, and we would use that for triangulation. But in here, we're going to triangulate using a robot. And what this robot, it does 3 things for us. It measures a horizontal angle, a vertical angle, and a slope distance. And if I've got a slope distance multiplied by the sine of the angle to the distance, what do I get? You get the elevation. So we can get an elevation. We have cosines. We're going to get the northings and eastings. So we'll get both. So all it does is 3 things, but we get a lot of data back from it. So we're going to use the horizontal angles, the vertical angles, and that slope distance, and we're going to find out where that drone is. All right? And we'll use the depth of that prism that it's following to the sonar system that's underneath, and we'll be able to map, and we'll go around. Now, this drone just came back from a nice exotic location. It was down in Miami, and in Miami, it was being used in a harbor because the harbor wouldn't let a person on a little paddle boat go around and map the depths of water around $15 million yachts. So those people that have the $15 million yachts like to know what the water looks like underneath. So this thing went down and it mapped several marinas down in Miami. And then it came back and got lost in Chicago for about 3 weeks, and then it made its way back to Milwaukee. But if you watch the robot, it's following it. It's using its camera system to watch that prism. What it's doing is it's sending out an invisible beam, near infrared signal, and it sends that out to using the distance, and then it looks for that prism. It can see that prism in the dark, so we could do this at night if we had to. And if you had a little squirrel, you could water ski. If everybody's seen Squeaky the squirrel water skiing, so you can water ski behind a TriDrone. Why do you think they made this a TriDrone instead of just a boat? What do you think? I'll show you. The water's really rocky. The TriDrone's really stable. So the guy who designed the boat here, they're going to use those sconces to stabilize that boat. It always stays level in the water. So I know the pool here is nice and calm, but if you were out in a pond that was a little rough and the wind was blowing or a wake came by, it would still stay stable and float and be level with the water. All right, who wants to drive? All right, drive it around. That's a beached whale there. All right, something else we brought. This plane is trying to destroy the boat. We're going to get outside.
I know that.
Nope. This is a laser scanner. There we go. Looks like a little R2-D2. So these are, they do the same thing. They give me angles and distances. Horizontal angle, vertical angle, slope distance. But where that one takes 1 second per reading, every second, this one shoots 1 million times. Okay? So we can actually get more data collected using the laser scanner. So a guy in, I want to say about mid-90s, his name was Ben Cassira. He had a problem. He was measuring bridges up, and he was never getting the right angle. He wasn't getting enough data from his total stations. So he went to a place called Radio Shack, got a bunch of parts, and he made the first laser scanner. That first laser scanner was about the size of a bus. It was giant. And since about 94, 95 to today, it got to this size. So we went from the size of a bus down to this. And the first one had these massive batteries too. So we've got it much smaller. So what this does is it takes 1 million readings a second while it's spinning. And we're going to put this right here, and we're going to take your pictures. You're all going to smile, and it's also going to map you for sizes. And we're stuck again.
This is not my fault.
Oh, I use it. All right.
Oh my.
Hope you got your swimsuit. Try backwards. Go, 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 go. So what this does is it does 1 million readings a second, and it spins around. It's also going to take a photograph, and it merges the photographs with the LiDAR information that comes back. LiDAR is light, distance, and range. Same things, we put these on planes. I can take that little drone, or take that sensor, and put it on a drone, and we can go ahead and have it fly over the school and map the outside of the school as well. So I'd mentioned earlier too about surveying with the police. We've done that. We also work in factories. So this robot here, the same model, is being used at Marinette Marine in the northern part of the state, and it builds littoral combat ships, but only the odd ones. So the even number ones are built down in Louisiana. The odd number Alabama. The odd number ones are built in Wisconsin, and we build littoral combat ships up here. So 1 through 13 has come out of the odd ones out of Wisconsin. And they use this to align the hulls because they're 770 feet long. They're so long, they have to constantly be measuring them as they're being built. And as the ship gets heavier and heavier, it starts to change shape until it gets in the water. So they use robots on there. Every odd numbered ship that goes out gets a theodolite to measure equipment on the ship when they're actually out at sea. So we use them for shipbuilding, they use them for aircraft, and other applications for surveying are in mines. So you get to go to mines, and then you get to travel a lot. If you like to travel, surveying, you can actually travel. I've actually worked out in Panama on the right at the border of Costa Rica and Panama, and we built oil production platforms down there. So you get to go down, live at the beach for a while, and do some surveying. So surveying can travel around, can do a lot of interesting things. We have 2 minutes, that's it. Oh. Okay, so we're scanning right now. It's actually scanning, as you see it spin. It scans, and it maps, and takes a photograph. Anybody ever hit a pothole while they're out driving in a car? Potholes? So surveyors put all those there. We map all the potholes so you know where they're at. I always joke when people ask me what do, I say we do surveying, we put the potholes out there, and at least catches people's attention. But the surveyor would go out and map those streets so that they could be redone and rebuilt. So that's one of the things that surveying does. There's lots of applications. Almost everything in construction has a surveyor go out first to do it. Anybody got any questions? Anybody got any answers? All right. Are we going back there to look at data or no? Oh, okay. Well, next time. Did they take the TriDrone test yet? Next week. All right, TriDrone. Remember that sign multiplied by the slope distance. That's an important one.
So a lot of these students right now are in the geometry class where they're working on the
Awesome. Awesome.
We're just finishing it.
It was, I used, let's say, I only ever used calculus once in my professional career, but I used trig every day. You know, I was very excited the day I'd use calculus in an engineering project. And it was basically calculus 1, so I didn't have to go to DQ. But trig, every day I use trigonometry. And one of the things that I get from clients all the time is data that's bad, and we have to figure it out, and it's always back to some trig. So, great class.
Thank you very much.
Thanks for coming out.